Have you started my time? Not yet? Okay. I need to know when you're going to start. Now? Okay. All right. This is like high stress. Okay, I'm Pam Jagger. I'm an associate professor in the School of Environment and Sustainability, and I want to take 10 seconds of my time. I want you to close your eyes and think about the kitchen in the house that you grew up in. Close your eyes. Just put yourself there for a minute. Okay, so you should all be in now sort of a happy, comfortable, warm place, nourishing place. I'm going to jar you a bit. So this is a photograph that is taken in one of my research sites in southern Malawi, which has been in the news of late because they're having a major flooding event as a result of a cyclone. So this is a typical kitchen in many, many places in the world. Okay, my animation is not working, so I'm just going to go with this. So the question I wanted to put to you is, how many people in the world do you think cook this way? And the answer is that an estimated 3 to 4 billion people globally, so almost half of the global population, are cooking with what we call solid fuels. So that's dung, crop residues, charcoal made from wood, or firewood. The implications of cooking this way are tremendous. There are a number of what we call externalities associated with being dependent on this as your primary fuel source. Primary among them for the purposes of this talk today are the contribution of all of this solid fuel burning to climate change. So because of the incomplete combustion process associated with the way that these fuels are being used, we have black carbon and brown carbon, which are short-lived climate forcers, as major contributors to the greenhouse gas mix and the emissions that are coming off of these effectively point source pollution events. We also have a health component associated with all of the smoke that's coming off as a result of this incomplete combustion process. And increasing awareness over the past couple of decades that there are more deaths attributed to exposure to household air pollution from cooking with solid fuels than from tuberculosis, malaria, and HIV/AIDS combined. So this is like the largest environmental health burden globally is from household air pollution. Ambient air pollution also emerging as one of these major environmental health risks. We're also concerned about reliance on solid fuels for issues related to deforestation and forest degradation, and then of course also tremendous impacts on people like the women pictured in the image here who are out collecting and carrying firewood home on a daily basis. So in terms of thinking about how we can solve this problem, we have a couple of options. So one that many of the people who have sort of a technology or an engineering background in the room would advocate for is, get everyone to make a transition to modern fuels. So get all of these folks access to the grid or some sort of off-grid system, get them access to liquefied petroleum gas, and allow them to cook effectively the way that we cook in our kitchens. An alternative approach is to promote improved biomass burning technologies. So if you're going for sort of a zero carbon outcome, if you can use renewable biomass in an efficient biomass burning technology, then that's also a pretty good option. So my group does work on how to think about what are the most feasible options in what I would call last mile distribution points. So places where people have very low incomes and where they're just at a very low level of economic development. So far from the grid, far from LPG distributions, etc. This is some work that we've done looking at an improved microgasification stove that's used in tandem with compressed biomass pellets in Rwanda. What we see is that if this system is used the way that it's intended to be used, so if it has good user compliance, it basically emulates the low level of emissions that you get with LPG, or liquefied petroleum gas. So there's a lot of potential for a system like this. However, there are very complex behavioral dimensions associated with getting people to use these types of technologies. So another very big aspect of the work that I do is trying to provide some evidence of, how much, if these technologies are provided, do people take them up? If they take them up, do they use them for a long period of time? Do they get rid of their higher polluting technologies when they adopt new technologies? And then how do you manage the supply chains for these new fuels? And I'll just leave you with this photograph. I took this picture in Chapel Hill, North Carolina. This is a Burmese refugee who lives in the US and presumably has some sort of modern cooking technology in his house. But he was at a local Burmese grocery purchasing this. It's a cook stove. It's effectively a metal bucket with a clay insert. And so he still prefers to do part of the cooking in his household using this relatively traditional basic technology because of these, just preferences that exist.